Hello, hello everyone. We are now officially live. This is so exciting. Welcome to today's project. We are continuing on with Nextwork's networking series and today's project on VPC peering. VPC peering is a really cool concept. Worlds are colliding today. We're going to get two VPCs to talk to each other. And I love the energy already in the chat. Thank you so much, everyone, for joining and catching up and doing this project with me today. We have Abdul Rahman coming in first. Rohit saying, waiting. We're now starting. Thank you for waiting, Rohit. Emmanuel Fubara saying hi. Kanan saying hi, next work. Amsa Priya saying hi, everyone. Ehab, hi everyone. Vamsi throwing a lovely emoji in there. And yeah, it's so cool to see that it's just a different time for everyone right now. Abdul says it's 10 a.m. in Nigeria. Jerome is waving hi too. Amsapriya, it's 2:32 p.m. for you over there. It's 9 p.m. here in New Zealand. Katleho says it's 11 a.m. in South Africa. Supriyo saying hi. Hi, Supriyo. Welcome back. We have Rohit saying it's also 2:30 over in India. Ehab, it's 12:05. Wow, Ehab, is it 12:05 midnight or noontime? Fubara, it's also 10 a.m. for you over there in Nigeria. Yeah, Supriyo, I didn't know you're in West Bengal. That's really cool. It's been a good couple of weeks having you over. And now you get to learn that you're in West Bengal in India. Adib, it's 5 p.m. Malaysia. Awesome. Rohit says, hello everyone, let's go already. Okay, Rohit, I get you. Jerome, it's 10:04 a.m. over in United Kingdom. We're like in opposite time zones, so it's cool to know that we can still be in the same place doing this project. B says, hello, hey. Yunshik, it's 6:05 from Korea. Wow. Yunshik, we're like in opposite, no, not opposite parts, but we're in very different parts of the world. It's my first time getting someone from Korea in this chat. Rose, it's 12:05 in Kenya. Ehab says it's your first time here. Wow, this chat is popping off already. Thank you so much. Etelvino says hello from Angola. Ika, it's 4 p.m. in Indonesia. What? Gangoda is also in India, 2:36 p.m. Ah, Akanksha is also in New Zealand. Hello. Murat says hello, smiley face. Hello, Murat. From Turkey. Yeah, Etelvino says it's 10 a.m. from Angola. My goodness, look at everyone in this Nextdoor community from all different parts of the world all coming together at the same time. Wow, we're so lucky to have each and every one of you. Shall we get started right away in today's project? Um, Please, at any point in time, if you have any questions at all, add them to the chat. In the meantime, let's get started. I think today's project, VPC peering, that difficulty level is a new one. We've never had this before, but it is getting a little spicy today because we are going to be adding just on top of everything that we've learned so far. And this is project 5 or 6. I think it's project 6 now in this series. So absolutely, it's getting hot in here. It's getting spicy. But we're going to be okay because we're going to be doing every single step of this project together. And absolutely, it is still beginner friendly. We're just going to take a bit of time to understand a few things. Because in the first 5 networking projects, we have created all of this stuff already. We've already learned about what are VPCs, we've created a public subnet, we've created an internet gateway, we have a route table going, what? We have a security group, network ACLs, private subnets, all of these components of a VPC. We've even ran connectivity tests by now, where connectivity tests is how we figure out whether parts of our network can actually talk to each other. You know, is our network set up properly? And connectivity tests in our last project helped us validate that yes, our VPC was set up in the best way possible. So that was awesome. And today we're going to be leveling up. We're going to be doing VPC peering. And peering, you can imagine, as you know, peer means, having someone next to you that you can I would say peer is someone that's just like having someone next to you, actually. And it could be like a buddy, a friend. A peer is also how we could describe like someone that's also a fellow person learning AWS. And who knew VPCs could also have peers? So absolutely, in this project, we're going to learn about VPC peering. We're going to be playing with two VPCs instead of just one. So the best part is that you still get to revise everything you've learned from the previous projects, but just in a new scenario. So you'll see what this means in a minute. But in the meantime, today we're definitely going to get ready to set up multiple VPCs. And then we're going to set up something called a VPC peering connection, which is how we can get those two VPCs to talk to each other. And then we're going to test the VPC peering connection with connectivity tests. So those are some 3 big milestones that we're going to be achieving together today. I'm so excited to be doing that. And again, just so that we can clarify this concept today, VPC peering means having a connection between two VPCs. So just having two VPCs like standalone wouldn't be called peering, but it becomes peering the moment you connect them so that they can talk to each other. And one good question that Amber asked before is, why does VPC peering actually exist? So we can actually just have a quick mention of that. VPC peering becomes so important when you want to share data with another AWS account or with another VPC in a very secure way. Because most of the time, if you want to, well, actually, without VPC peering, if you want a VPC to talk to another VPC, they're going to have to talk through the public internet. As we already know, a VPC is your own entire private city in this entire country called your AWS region. So absolutely, even if you have two VPCs in the same account, if you want them to talk to each other, you usually have to use the public internet. They're just that isolated already, even if they're from the same like AWS account. And that's why VPC peering exists, because I guess the public internet might not be the most secure way to send data. There are absolutely more secure ways that you can get data across with direct connections. And that's why VPC peering exists, so that you can directly connect to something off of the internet. And that is just a much, much better way to transfer data and keep it, I guess, protected from potential attacks, from exposure. So I hope that's very clear with everyone. Are you ready to set up a VPC peering connection today? I hope you are. Add a yes to the chat if you are today. Or actually, I've heard that some people like to watch these YouTube lives just as a way to chill while you're studying on your own. And I think that's such an awesome way to be using a YouTube live as well. So hi to you, and a special shout out to you if that's how you like to use a YouTube live, or a live project demo, as we call it. Cool. So with that intro, let us get started. I would say, by the way, this is a quick introduction to the architecture diagram of what you're about to build. And I know it might look a bit scary because we now have two VPCs going, but it honestly is just like a single VPC's setup, except that you've just now duplicated it. You just gone copy, paste. And the one thing that we're also adding to this architecture diagram is that peering connection in the middle there. So you can see it looking cute and cozy over here. That's going to help us connect traffic from one VPC all the way to the other VPC. Yeah, it's a very, very, very important piece of the puzzle to get that peering connection going. All right, I think we're ready. And let us start by answering this cute little question at the very start of our guide. What are we here to do today? In your own words, explain what you'll be doing in today's project. Isn't it a little sneaky? I don't think we've ever actually had a question like this at the very start of a project, but we are going to now, because it's a great way for us to be like, oh, what am I doing? Let's have a quick recap. So today we, because it's all of us doing this project together, today we are setting up a VPC peering connection, which means directly connecting two VPCs together so data transfers between them so data transfers between them are secure and out, and not, I will say actually just be very clear, and not across the public internet. And not across, another great way to say this is it bypasses the public internet. Yeah, so today we're setting up a VPC peering connection, which means directly connecting two VPCs together, so data transfers between them are secure and not across the public internet. Nice. So that's the key, like that's the essence of what we're doing today. This also involves setting up two individual VPCs if you'd like to add that. But in the meantime, I'm quite happy with this, so let's click done. And yeah, if you want documentation for your project, all you have to do is just answer all of those questions, just like how we answered that question just now and click done. We just need to answer all of these tasks, and that creates documentation for us. If we don't answer all the tasks, unfortunately, the button to create documentation for us is going to be locked up. It's going to look a bit like this. At the bottom of your page, it still says still task to complete, which means you're not able to find your documentation yet. But we're going to make sure we get documentation today. How are we going to do that? We're going to get documentation by making sure that all of these tasks have been answered. So I look forward to answering each of those questions with you. I really like the way everyone in this community answers questions. It's been a joy reading everyone's documentation. So maybe we'll be answering a lot of these questions in the chat together. That'll be awesome. Yeah, a quick heads up as you do this project that you can't edit your responses or screenshots after you submit them. So once you click done, once that background is green, you won't be able to edit your responses. So let's make sure that when we click done, we are submitting an answer that we are 100% sure of and we're proud of. Editing responses is going to be something that comes through eventually. But in the meantime, while our engineers are working very hard creating that feature, we'll just be making sure that each of those responses we send through are final for us. But yes, absolutely, to everyone that's been asking us, please, can I edit my responses? That feature will be coming through soon. Cool. All right, intro over, everyone. We're going to set up our VPC in minutes, and let us get started. So Murat says, how do I reach this lab? The link to this lab is in the description box. So if you click on that and you select this lab from the navigation panel, you'll be able to find it right away. If you need help finding the correct one, actually, this is how you can get there. So how you can get there is going link.nexo.org/YouTube on your browser. And typically when you look at the Nextwork homepage, you're going to be like, oh, it's just one project, host the website on Amazon S3. No, not really. All you have to do is notice this little bar at the bottom that says My Projects. Click on that. And then click on Networks on the left-hand navigation panel. Do you see this navigation panel? Click on Networks here, and then click on VPC Peering, and it's going to take you to this guide. So I hope you'll get there okay, Murat. Let us know in the chat once you find it. All right. So how are we going to set up our VPC in literally minutes? We are going to be doing this by using the VPC wizard, or that resource map that we learned about in the previous projects. So it is actually going to take us 2 minutes to set up two VPCs. And I would say that's super fast. But that's exactly what we're going to be doing in today's project. Very cool. All right, so in this step, we are using the VPC resource map, launch, I would say, wizard to create two VPCs and their components in just minutes. Cool. Let's click done for that. And what you have to do is first log into your account, and you also just need to head to VPC in your console. So how you can do that is once you've logged into your AWS account, ideally with an IAM admin user. And if you don't have an IAM admin user, you just have to check out the link in the description. It teaches you how to create that. You can still use this the root user account in your AWS account, but IAM users are absolutely the most secure way. Once you logged in into your AWS account, we're going to use that handy search bar at the top here, and we're going to search up something called VPC. Now, VPC becomes that very handy top search result, so we'll click into that. And from the left-hand navigation bar, we're going to click on Your VPCs to see that option to create a new VPC for us. Perfect. So once you're here, we're going to use VPC and more. So make sure that in that first option that you get, we're going to click on VPC and more. So boom, you're going to see that the resource map is up here and it says, I'm ready. In one flow, we're not just creating the VPC itself, we're also going to be creating all of the other components that we've learned about: subnets, route tables, internet gateway, even network ACL. So it's not even mentioned in here, but it's absolutely getting created as well. So for name tag auto generation today, so name tag auto generation becomes, the name that pops up at the start of every resource's name. And for the first VPC we're creating, don't forget we're setting up 2 VPCs. All right, so we're going to want to make sure that with the name tag that we're creating, the VPCs that we set up are going to be very easily differentiated from each other. So we're going to make the names quite unique for each VPC. How are we going to make them unique? We have a very simple solution. The first one is going to be called Network 1. Boom! Unique name. That's all you needed to do. So now Network 1 is going to have a CIDR block of, let's make it unique again so it's very easy to identify. We're going to call it 10.1.0.0/16, and that's going to be the range of addresses within VPC1. And is there going to be a CIDR block, IPv6 CIDR block? We don't need that. The tenancy, we'll keep it as default. Number of availability zones, for this option, we're going to select just one availability zone. And then for public subnets, we just need one. And check out just how your resource map gets smaller already the moment you choose just one availability zone. Now, availability zones is something that we first talked about in the previous project, so I'd recommend that you check out the previous project in the series if you're like, oh, what are these things? But to recap, an availability zone is pretty much an area in the AWS region where the resources in your VPC will be launched. Because at the end of the day, what is cloud computing? Cloud computing is the ability for you to lend resources or lend compute power from AWS. In our case, we're using AWS, but from another cloud service provider. At the end of the day, there's actually going to be a physical server somewhere in the world that's out there launching the resources on your behalf. So you're not launching it from your own laptop, you're launching it from another server somewhere out there. And then the availability zone is pretty much an area where AWS has their own physical servers that's launching those resources in the background for you. Typically, having multiple availability zones is the ideal case because servers can actually go down, entire areas can actually crash. It's not common, but it can happen. So having multiple availability zones is the way for you to protect yourself so that if one availability zone, so if one group of servers or data centers in AWS's region goes down, the other one, your backup option, is going to be like, oh, don't worry, I'm right here. It's going to go get up and running. In our case, since this project is just going to be for 1 hour, we're not really keeping this project. We just need one availability zone, and then we're going to delete everything at the end. But if you're actually deploying like a very serious project that you're going to keep for like weeks or months, or it's going to be ongoing for a long time, definitely make sure you're selecting multiple availability zones. But yes, it's just so good how simple it is with a single availability zone. And you know what? in today's project, we're actually just going to be creating 0 private subnets. We don't even need a private subnet. We just need the public one. So again, check your resource map and see, again, it got simpler. The number of subnets is now just 1, and we only have 1 route table going on. We only have an internet gateway that's connected to that public subnet. We don't even need a private subnet for this project. And we absolutely don't need NAT gateways or a VPC endpoint as well. So we're going to click none and none for those 2 other options. Check your resource map one more time. See how simple it got now. Internet for network connections is only 1 resource getting connected. It's the internet gateway. This is absolutely all we need for our VPC today. So this looks amazing. Perfect. All we have to do now is click create VPC and off it goes. So what I'm going to be scrolling through now is all of the settings that we've already just selected. And once you've created your VPC, look at how quickly all of the VPC's resources just get created. When you get very familiar with this wizard, it becomes such a powerful tool for just launching things like boom, 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 just like that. There we go. We can view the VPC now. Can you see yours once you have yours up? Can you see your VPC that says Network 1 VPC? When you scroll down, can you still see your resource map that shows you all of the resources that's just been created for you? How good is that? How good is that? All right, and a quick shout out to everyone in the chat. Wow, Abhishek says hello, Natasha. Hi, Abhishek. Ehab says Israel here. My goodness, we really are all across the world, aren't we? Rohit says, Natasha, you are the best. Thank you, Rohit. Shrida says, hello, Natasha. Ehab mentions, I like the way you explain things. Thank you. And I really appreciate you being here as well. Murat says, how to reach this lab. Yep, I hope the link works for you. And Karel says, hello from Barcelona, Spain. Wow, Karel. Hi, this is so cool. Barcelona sounds like an amazing city. Catlejo says, I'm panicking and can't find it. Sorry, I am using one screen. Found it. Oh my gosh, you took me on a roller coaster there, Catlejo. I'm glad you found it. Gangada says, is it okay to create individual resources other than VPC and more? Of course you can. Of course you can create individual resources. We talk about how to create those in the first 3 projects of this series, so you can follow the guides there to create those resources. VPC and more is just here to help us create it very, very quickly. Adib says, is Net Gateway used with private subnets? Yes, they are. Joe says, good evening, Nat. Hey, Joe's here. I'm glad to be here tonight as well. Me too. I'm so glad to see you here, Joe. Big shout out to you. Kalejo says, can I ask how will the projects be documented for LinkedIn? Oh, you will know exactly how to document these projects for LinkedIn at the end of this project demo. So I hope you get to stick around to see it. But if you want the spoiler, you will just need to answer all of the questions in your project guide. You can scroll down, click on that blue button at the bottom, and then there's going to be instructions on how you can share your project on LinkedIn there as well. Or you can click on that handy share your project, this link. The share your project link in your project guide. There's going to be kind of like a table of contents on the right hand side. Select the share your project link. That's the second to last link in the table of contents when you're looking at the project guide. I hope that helps. Gangara says, could you please provide notes as well? It will be helpful, thanks. Oh, I wish we could. I wonder what kind of notes you're looking for, Gangara. Tell me more. Typically what we do is the notes are already integrated into the project guide, so you get to learn what the concepts are within the step-by-step guide. If you haven't seen any of these before, I'd highly recommend you check out this guide itself that I'm scrolling through right now. But let me know if there are any other notes you're wanting to see but you haven't found yet in a project guide. We can absolutely talk about those too. Cool. So we're going to set up VPC2 in the exact same way. But again, let's do it super fast by using the VPC wizard, by using the resource map creator. Here on the name tag auto generation, again, we want a very unique name. So we're going to call it Network 2. And then for the CIDR block, what is the CIDR block that we want to use? Don't forget, the other VPC, Network 1, uses 10.1.0.0. So for Network 2, Let's make things very consistent by calling it 10.2.0.0. So why do they need to be unique? Why can't I just use exact same CIDR block like this? You know, two VPCs, same CIDR block. What's the issue here? So each VPC must have a very unique CIDR block so the IP addresses of their resources don't overlap. To put it simply, imagine if you had two cities that are supposed to be isolated from each other, but then every single house or every single street overlaps between these two cities. You know, if I have a street called Nextwick Street in VPC 1, there's going to be a Nextwick Street in VPC 2. If I have 10 houses on Nextwick Street in VPC 1, 10 houses in VPC on Nexus Street in VPC 2 as well. Now, this is okay if you're just going to live within your city. What I mean by this is imagine if all the traffic is just going within your city and maybe with the public internet, within your city and with the public internet. But imagine if traffic needs to get from one VPC to another VPC. Imagine telling a resource, imagine telling someone that lives in House 5 in Nexwick Street in VPC 1 and be like, hey, I see you want to get to this specific thing in VPC 2. Their address is also House 5 in on Nexwick Street, but just in VPC 2. Can you get there? They're actually going to be a little confused because the route tables, for example, that's trying to be the GPS for everyone will be like, oh, okay, I see you're trying to get to House 5 in Nexwick Street. Let me try get you there. And it's going to get really, really confused because it's going to say, oh, we have the exact same address within this VPC already. Are you sure you just don't want to stay within this VPC? Your route table will actually get very, very confused and it won't know how to route your traffic to the other VPC. So we absolutely need very unique CIDR blocks if we're going to set up peering connections, if we're going to try to make these two VPCs talk to each other. So let's keep that as 10.2.0.0/16. And again, same settings for the rest. So one availability zone. We want one public subnet, 0 private subnets, no NAT gateways, and no VPC endpoints. We don't need these. If you're curious, by the way, VPC endpoints, amazing concept. Can't wait for you to learn about this in a future project in this series. We're going to come back to this concept, VPC endpoints. And let's create this VPC. Here we go, VPC 2. Look at that. How fast was that? Challenge yourself. Do you think you could create VPC 2 in just 30 seconds? I would love to know if you can. Add that to the chat if you could. That would be super impressive. And we have some more action going on in the chat. So Priya says, how does the VPC peering differ and functions in public and private networks? I mean, how they work during their operations practically. So VPC peering helps with connecting two different VPCs. So can you make traffic from one VPC go to the other VPC? How does it differ in functions between public and private subnets is quite an interesting question because technically VPC peering, you shouldn't have the connection itself. There should be no problem in setting that up for a private subnet or for public subnets. That should be completely possible because it's a direct connection. You're not even using the public internet anymore for them to communicate, so you won't need extra components like NAT gateways, to set up connections between private subnets. We're just keeping things very, very simple in today's project, so that's why we're just using a public subnet. If you want VPC peering connections between private subnets, you absolutely can do that as well. And it's not going to be any special setup required to make that happen. It's just that we're keeping things simple for our project, so we're just going to keep it to one subnet. Fubara says, at Adib, yes, NAT gateways used with private subnets. Legend for Fubara. So they can use the internet, but prevents inbound traffic from the internet. A star to you, my man. A star to Fubara. Akio says, is this coffee or tea? It's tea. A big fan of green tea. Supriyo says, also one request. Please kindly share the PDF documentation of this project stepwise and make them available for download in the website, please, as it will be helpful. Let us know if you're able to just download, just print this documentation as a PDF yourself. For example, if you're on if you're looking at the project guide, are you able to just press Command P on your page and print it off like this? Does that answer your question, Supriya, or would you prefer having PDFs still? And Ehab says, very easy. It is, isn't it? Akil, coming back to your question on is that coffee or tea? I would love to know what your preference is. Do you like coffee better or do you like tea better? Just out of curiosity. Anyone else in the chat? Let's vote right now. Coffee or tea? I am team tea, but I know there are a lot of people in team coffee as well. Cool. So we have just created our second VPC. So let's take a screenshot of VPC2's resource map and let's answer a few questions. Okay. Let us answer a few questions right now. Let's take the screenshot. Oof! Look at that. My screen looks beautiful and all set up for a screenshot right now. So let's take a screenshot of the resource map like this. And let's drag that into our step-by-step guide. Boop! Ready. And let's answer some questions. What did you launch in this step? How many subnets did you create? Ooh, I started my project by launching. What did we launch, everyone? What did we launch? We launched 2 VPCs. We did it. We started the project by launching. I like using we now for all of this since we're doing this project together. We started our project by launching 2 VPCs. They have unique CIDR blocks and they each have 1 public subnet. Cool. Next question. Why are the IPv4 CIDR blocks for VPCs 1 and 2 unique? So the CIDR blocks for VPCs 1 and 2 they have to be unique because so let's answer these prompts. So let's say the CIDR blocks for VPCs 1 and 2 are 10.1.0.0/16 and 10.2.0.0/16 respectively. They have to be unique because once you set up a VPC peering connection, route tables need unique addresses for correct routing across VPCs. Amazing. Beautiful. Stunning. Mwah. I think that's good. That's good. The CIDR blocks for VPCs 1 and 2 are 10.1.0.0 and 10.2.0.0/16 respectively. So they have to be unique because once you set up a VPC peering connection, route tables need unique addresses for correct routing across VPCs. Once you set up a VPC peering connection between 2 VPCs, like this. I think that's great. I'm going to click done. I think that answer is good for us. Okay, and a big shout out to everyone in the chat for voting. This is very helpful. This is T. Wesley is also a T person. Supriya says perfect, thanks about the PDF, so I'm glad that helped. Vamsi is a coffee person. Oh, the more you know. Katleho likes hot chocolate. You have taste, Kaleho. We are hot chocolate fans as well. Ehab loves iced coffee. Oh, nice, Ehab. Supriyo likes green tea too. Lol spams. You're using a spam account today. Welcome though. Says, I love tea. What's your favorite tea? Akil says, you're a coffee person. I see. Thank you so much, Kaleho, for mentioning in the chat that you can't seem to get the screen to attach your screenshots. And Joe says, hey, oh, okay. Kaleho, if you can't get your screen to attach screenshots, here's the quick advice. So if you can't get it to attach screenshots, 2 things to test. First thing to test, oh, it's already updated. First thing to test is, I'm going to try to find one where I can attach a screenshot maybe. Can I attach a screenshot here? First thing to test is, can you just click to upload? And then this will bring up a window where you can select screenshots directly. That should work, and you should be able to click on something, double click on it, and it should attach a screenshot for you. Please check if that works as well. If that doesn't work, can you try dragging and dropping the screenshot directly into the screen? One of those two options should work. If they don't, we can definitely talk about this in the community. Let's solve that problem for you together. But thanks for asking that question. Akash says, could you please share the docs with us? You got this, Akash, of course. Yeah. Joe, thank you for your advice. Yeah, docs can be shared, but if you go through the project yourself, docs could be unique to you too. Yeah, I think that's definitely the case for documentation. And Akash, just in case, if you were just wanting the step-by-step guide, like this guide itself, you can definitely have that. I'm just gonna add that to the chat so you can see it now. Akash, so let me add that to the chat. Here you go. Cool, here you go. That's a link to the step-by-step guide. And Joe says, totally off topic, but I have my Nextwork beanie on right now. It is so good. And Michael Winton says, hello everyone, joining a bit late, but excited to learn with you all. Michael, welcome, and it's so good to learn with you. Murat says, you like Turkish tea. Abdul is also a tea person. Joe asks, can we choose boba and bubble tea? That's 200 IQ stuff right there. Of course you can, Joe. Yeah, and Kalejo says, how do I get to take a screenshot? It differs depending on your computer. I would honestly search up Google, how can I take a screenshot, and then add whatever computer or laptop or device you're using, because it honestly looks a little different for everyone. And there are different shortcuts for every computer as well. If I'm using a Mac, I have my own screenshot. I think I have my own shortcut. I think if you're using Windows, you look for something called a snipping tool, but someone correct me if I'm wrong, because the last time, I'm not sure if snipping tool is still the tool that you would use to take a screenshot. Cool beans. Cool beans. That was step 1 done. My goodness, let's move on to step 2. We're gonna set up that peering connection now. So, woohoo! Now that you have 2 VPCs ready to go, we have to set that up. Let's bridge them together with a peering connection. So in this step, you're going to set up that connecting link between 2 VPCs. Do you see how we have one VPC over here, we have a second VPC over here, and how are we going to set up that direct connection so they can talk? We're going to use a VPC peering connection. We're now here. We're going to be creating this now in this step. I'm loving the chat today. Everyone, you're so funny, everyone. Yeah, Murat says, thanks for sharing. I'm glad that helped. Gangada says, you're doing great work. Ehab says, quick question, what OS are you using? I'm using Mac. I'm a Mac user. Wesley says, Windows Shift S to take a screenshot with Windows. Michael says, 200 IQ. Let's go. Absolutely. I feel like everyone in this chat combined, we're like 1 million IQ probably. Random thought. All right. So what are we doing in this step? In this step, we are setting up a VPC peering connection, which is a component, which is a VPC component, I can say, a VPC component designed to directly connect 2 VPCs together. Awesome. That's what we're creating. Click done. All right, so still in the VPC console, we're going to click on peering connection in that left-hand navigation panel here. And very cool. Now you might be thinking, okay, I know we just said it's made for direct connections, but what is it really? Why is it here? So we're going to go into a bit more of the technical details now by explaining what is a VPC peering connection. So get ready, hold on tight. This is probably like the key definition to learn about in today's project. So how do peering connections work? A peering connection lets VPCs and their resources route traffic between them using their private IP addresses. Private IP addresses. So this means data can now be transferred between VPCs without going through the public internet. So this piece of insight honestly ties together a lot of the things that we've learned about VPCs in the past. Why is it that resources in a public subnet have a public IP address? It's so that anyone from the public internet can reach them using their public IP address. So why is it that private resources don't have a public IP address? Well, we always wanted to keep private resources in a private subnet to be completely secure and away from potential attacks from the public internet. So they have a private address. A private address is something that can't be reached from the public internet. So we've just talked about how normally data transfers between VPCs would have to go through the public internet. So it would have to look like this. Say some traffic from VPC 1 wants to get to VPC 2, it's going to have to go all the way out of the resource. In this case, it's an EC2 instance, as go all the way out of the resource, outside of the VPC, as to go through the internet gateway, reach the internet, and then within the public internet, find its way into VPC 2. So do you see how it has to go through the public internet just to reach another VPC? Is that ideal for us? Do we really like that? Because the thing is, having traffic in the public internet really is not as secure as being able to just go through things privately. So what we really want to know is, how can I use my private IP address so that we can route traffic between each other like we're in private subnets, like we're just completely directly away from the public internet. So that's why we have this thing now. We're going to use something called a peering connection that's going to sit just between our two VPCs so that we will never have to get traffic outside into the public. It will still sit inside, I guess, a more private space to get traffic to your other VPC. Cool. I hope that was helpful. Let us know in the chat if you'd like more explanations around what is a VPC peering connection, why does it work. But the key thing to really know is that a VPC peering connection is able to get two VPCs to talk to each other privately because they can now use their private IP address instead of having to use their public IP address. Cool. So once we click on peering connections, let's click on create peering connection on the top right-hand corner over here. And let us set up a peering connection now. So we're going to call it VPC1, arrow, VPC2. That's going to be the name of our peering connection. And then we're going to select a local VPC to peer with. Let us select Network 1 VPC as our requester. And a requester is basically the VPC that initiates a peering connection. You can think of the requester as the VPC that's like sending a friend request. Hey, can we be friends? Can we be connected directly so we don't have to talk over the public internet? Can we do that? So once we've selected Network 1, now we can select, as Network 1, who are you sending this friend request to? Yep, I'm sending this friend request to another VPC within my account. This other VPC is also in the same region. It's not anywhere too far. And their ID, they are Network VPC and Network 2 VPC. So they're the acceptor. So acceptor, just again, like a Facebook friend request, they're going to receive this request. And they have the power to accept the request, say, yeah, we can be friends. Let's be directly connected. Or they can reject the request. They'd be like, no, I don't want to be friends with you. So you can see how you need both in order to set up a peering connection. You can't just have one saying like, I want to be friends with you and just directly create a peering connection. The other VPC needs to accept that in order for the peering connection to exist. I just love, by the way, side note, I just love that you can actually click on another account and you can peer with a whole other AWS account. So man, imagine if we can get to know each other as AWS accounts as well, and we can share with each other our account IDs and play with this project as friends, and I can try peer with your account, a VPC in your account. I think that could be very fun. Okay, so once you've set this up, you've clicked that your VPC ID is Network 2 VPC. You're going to scroll down and you're just going to click on Create Peering Connection at the very bottom. Done. That was super fast, wasn't it? Just like that, we have created the peering connection. Okay, we have created this thing. It now exists in this world now. You've created it. A key topic in every single project that we have, networking project that we have especially, is that it's not just the components you need to set up, it's also the links. Okay, so we have set this up now. We've set up this peering connection. We now need to set up the links, okay? Because without the links, none of this would work. We could have the components, but they'll just be sitting somewhere in the abyss, not being connected to all of your other components. So let's also connect our peering connection with the VPCs that we've set up. So first, what you're going to have to do is you're going to have to accept this friend request as the acceptor now. So we've set up the VPC peering connection, and now you're going to click on Actions, and you're going to click on Accept Request as a way to kind of say like, oh yeah, I'm going to accept this VPC peering connection, and I'm going to click on Accept Request. Cool. So what you've just done there is you've accepted the VPC peering connection request, and now technically VPCs 1 and 2 can be connected together now through the VPC peering connection you've set up. Oof. So take a screenshot of the Select Another VPC to Peer With section of your connection setup page. I'm laughing. Did you see that I froze just now? I was like, take a screenshot of. Why is that? It's because I definitely went through that step a bit too quickly and did not take a screenshot when I was supposed to. So I'm just going to mimic that step again. So I'm just repeating the step purely for the sake of taking that screenshot now. And let us drag that screenshot into the screen. Done. We're going to pretend that was my first time doing that. And then, yeah, we are going to also take a screenshot of the pop-up that comes up when you accept the peering request. Oh, team, I definitely clicked through buttons a bit too quickly. I was a bit too eager now today, wasn't I? So let's see if I can actually set up the exact same peering connection again. And then now this time, can I accept the request? Oh, it's being difficult. All right, we just have our peering connection. Oh, okay, what's happened is, you know how I just tried to create the exact same peering connection and I couldn't click on accept request again? It was because AWS has already just recognized that I've created this peering connection before. So there's no need to do accepting twice. You know, I've already accepted it the first time. That means I don't really have a screenshot for this page, you know, select accept request. But I think that's totally okay. We can use an alternative. My alternative is just to use this as my screenshot. Okay, so this screenshot that I'm taking is just a details page for a peering connection. Cool, I think that works pretty well. Do you think so too? Okay, cool. Now, before we move on, you might be wondering, why did I have to accept a request? You know, wasn't that interesting wording? You know, that we had to click on accept request? We were the one that created that, weren't we? Why do we have to accept it? So what happens just now was when we created the request, we were creating it as VPC1. And when we accepted the request, we were acting as VPC2. We were on the other side of that connection request now, and we were like, oh yeah, as VPC2, I'm also going to accept it. So absolutely, you need both steps to set up that peering connection. Cool. And let's modify the route tables. So unfortunately, again, I skipped through this a bit too quickly, so you didn't get to see it. But we're gonna click on a button that says "Modify My Route Tables." Now it's a button that pops up next to a green banner. If you also don't see that button, the other way to get there is just by clicking on Route Tables on your left-hand navigation panel. That's all that button did. It just jumps you to this page over here. Cool. And we're gonna update our route tables. So why are we updating our route tables? Have a quick think. Why are we updating our route tables, and what are we here to do? If you're feeling curious, add your answer to the chat as well, and let's talk about it. Why are we updating the route tables today as well? Oh, in the meantime, let us chat and let us talk about what's popping in the chat, shall we? Owolabi says, "This is my first live, and I'm very pleased with what you're doing here. Thank you. This is great work." Wow. Owolabi, thank you so much. Thank you. And a big kudos to everyone in the community as well for making this live such a warm and lively place. I don't think it would be such a great live without each and every one of you. Abdul Rahman says, "At Windows, use PRTSCR. Print screen? Is that what that stands for?" I love that. I didn't even know that kind of function exists. Supriyo says, "Be right back." We're gonna wait for you, Supriyo. Ah, you're back already. I love that you updated us. This is so cool. Katleho says, "Thanks, Wesley." Joe says, "Ooh, Mac, I don't know if we can be friends anymore." Joe? Excuse me, sir? What do you mean? What do you mean? Do not disrespect Mac over here. Ehab says, "Hee, very helpful." Trul says, "Pros with that is less MS between VPCs rather than out of internet." T. Less MS. What does MS mean? I might be missing some context here. I would love to know, Truls. You said something very interesting there. Ehab is giving me the sweat smile face. Sometimes we have that feeling. Yes, thank you so much for relating. Gangada says mutual understanding between VPC should be there. Gangada says they became friends now. Yeah, they've become friends now. Now that VPC2 has accepted VPC's one's friend request. All right, I noticed we haven't been able to say what we're doing with our route tables here. So I'm gonna imagine that this means we're gonna want to understand this together a bit closely. So let us take a second to understand why we need to update our route tables. Remember how we said before that it's not just the components that are important to set up, it's the connections between the components. So we have a VPC peering connection. We have accepted the request. So the peering connection now knows which two VPCs to connect with. But a question that we haven't answered yet is, do resources or does traffic in one VPC know how to get to the other VPC? Do they actually know how to find the way to each other yet? The VPC peering connection is like a bridge. It's like a bridge between two cities. But traffic in your VPC or resources in your VPC don't automatically know where that bridge is. It's almost like, imagine if you've done the hard work of setting up a VPC peering connection and you do a live broadcast to all citizens in my city, to all resources in my VPC. Great news, we now have a peering connection directly to the other VPC. Okay, bye. And you just say that, you drop the mic, you go. Then all the resources will be like, "Oh, great, we have a direct peering connection. No more needing to go through the public internet to get traffic across the line." Where's that bridge? Where's the bridge? Take me there. You need your route tables to know exactly where to go, or you need your route tables to navigate traffic between your resources to say, "Oh, you want to get to the other VPC? Here's how." That isn't set up yet. Our route tables are actually a little lost. They don't actually know how to route traffic between your VPCs yet. So let's set that up. A shout out to all of the people that got that answer, by the way. Murat saying to route data traffic to the other VPC, correct. Ehab, we need to know who we are talking to and how to get to them. Liu says route table maybe to hold the source and destination addresses. Very good one. Oh, True says milliseconds. That was ms. Oh, you're right. Thanks. Regarding network latency. Very, very true. So what Truth is also saying is because we have a direct peering connection now, traffic or getting to traffic going from one VPC to the other is also going to be faster now. Less milliseconds. Very cool. Thanks for that, Truth. Really, really helpful point. All right, so let us talk about the route tables one more time. When you click on a route table over here, you're going to notice that they've also named the route tables after each VPC. Very, very useful. So Network 1, RTB public is, VPC1's public route table. Once you click on that, just drag this up and click on the routes tab, and you're going to see this is exactly the GPS that all the resources in VPC1. This is these are the routes that's in that GPS. So our route table currently only has 2 routes. One route is getting everything through the internet gateway, and the other route is local traffic. So if a resource in your VPC just wants to get to another resource in your VPC, easy. They'll just go through the local target, which means all they have to do is use a specific route that's designed for local communication within your VPC. Now there's also another destination. There's also another route setup that says 0.0.0.0/0, and there's a target of internet gateway. Means okay, if your destination isn't within the VPC, it's somewhere else, you're gonna go to the internet gateway, and you might remember the internet gateway is this thing over here. You're gonna go to the internet gateway, and where does the internet gateway take you? The public internet. So right now, traffic can either stay within the VPC to stay here, or go through the entire internet. There's no route right now set up for directly connecting to the peering connection. This route doesn't exist yet. You can imagine this arrow doesn't exist yet. So let's set that up. Let's make sure our route table can tell resources or tell traffic how to get to the other VPC in a direct way using the peering connection you set up. Click on Edit Routes here. Okay, click on Edit Routes here, and then add a new route that says if you want to get to the other VPC or resource at the other VPC, you're going to use the peering connection. So how we're going to do that is here, let's type in the CIDR block to the other VPC. So that's 10.2.0.0/16 as the destination. Apologies, everyone, that there is a typo right now actually in here. So this should be 10.2.0.0, not 10.1.0.0/16. But if you want, let us type in 10.1.0.0/16 to understand what's going on here. And then you're going to say, if you're wanting to get to your other VPC, this is how. Oh, actually, I chose the wrong thing. You're going to use the peering connection, right? We're saying, hey, if you want to get there, use the peering connection. And then this is the ID of the peering connection. Let's select the one that we've just created. Okay, so we set up a peering connection. We're going to say if you want to get to the other VPC, use the peering connection. This is how you're going to do it. Don't go through the internet. Don't go through the public internet anymore. You're just going to use the peering connection now. Now we're going to click on Save Changes and look at what happens. What? There was an error with editing those routes. The destination CIDR block 10.1.0/16 is equal to or more specific than one of this VPC's CIDR blocks. This route can target only an interface or an instance. Interesting, right? So this is very, very cool. we needed to see this error. That was on purpose. That was by design. What this error message meant was route tables cannot differentiate between local and remote destinations if they share the same CIDR block. Okay, go back. Look at how, if we were to just keep on going with 10.1.0.0 set 16, your route table will now have 2 routes with the same destination. And your route table will be like, uh-oh, you can't do that, my friend. I can only use 1 target per destination. So if you already have a destination like this, you can only have 1 target assigned to that. You can't say also go through this target. Your route table is going to get very, very confused. That's exactly why back in step 1, it was so important that our 2 VPCs had unique CIDR blocks. Why was it that we were so adamant that the other VPC must have the CIDR block 10.2.0.0 so that we could avoid this issue down the line? Imagine if they both had the same CIDR block. We'd definitely get into trouble in this stage when we're trying to set up our route tables. So I hope that was clear. Once it's done, you can select on Save Changes one more time. We've fixed our table. We've updated it to 10.2.0.0, so that's 16. And then let's click on Save Changes. Success. No more error messages. So very, very good. We've troubleshooted that immediately. We already have updated routes in the route table, and now our route table is looking clean. Look at this route table. It says, this is the route table for VPC 1. It says, if you want to get to traffic within the VPC, just use the local target or the local route that's going to get you there. This keeps communication internal. If you want to get to VPC 2, okay, if the destination is anything that's within VPC 2's CIDR block, you're going to use the peering connection that you've set up. If you're trying to get to somewhere that's none of the above, you're going to somewhere beyond those 2 CIDR blocks, you're going to use the internet gateway. So you're going to use the public internet to get there. But lucky for us, happy days, this is exactly what we want to see for our route table. The routes have all set up now. Now, challenge yourself. Can you set up this equivalent, what we've just set up with this route table? Can you set this up for VPC 2's route table? What do you think? Can we challenge ourselves to do that? Let's see who's faster. I'll do this now. Let's see if you can do this at the same time as me and let's race each other. So I'm going to click on Network 2, route table public. I'm going to click on routes. I'm going to edit the routes. Again, we're going to add a new route. This time there's going to be the destination 10.1.0.0/16. Just like that, we're going to create a route to VPC 1, from VPC 2. And then we're going to select peering connection as how we're going to get there. Whoa, where did peering connection go? It's right here. And then we're going to select the peering connection we've set up. Okay, we're going to save our changes. Done. Were you faster than me? Did you do it before I did it? Ooh, a T if you did. Congrats to you if you did. You're a pro. Okay, so we're going to take a screenshot of VPC 2's updated routes tab. So let's take a screenshot. It's going to look like this. Screenshot taken. And let's put it here. All right, we've uploaded our screenshot now. And then we're going to answer this cute question over here. Why did you add a new route to your VPC's route tables? All right, so we're going to put it here. After accepting a peering connection, our VPC's route tables need to be updated because, why is that? Because traffic between VPCs still need directions from the route table, sending directions from each VPC's route table in order to get to the other VPC. The default route table doesn't have a route using the, oh my god, run out of characters just like that. That was way too fast. After accepting a peering connection. Okay, I'm just gonna delete that first part. Our VPC's route tables need to be updated because traffic between VPCs still need directions, because I would say traffic, because, okay, maybe I'll be more concise and just say because the default route table doesn't have a route using the peering connection yet. This needs to be set up so that resources can be directed to the peering connection when trying to reach the other VPC. Call me a pro because we are now within the character limit. Phew for that. Okay, next question. What was the new route you added to your VPC's route tables? My VPC's new routes have a destination of, the route's targets was, aha. So our VPC's new route tables have a destination of, what's the destination? It was the other VPC's CIDR block. The route's target was the peering connection I set up. The peering connection. Done. And that's how we updated the route table. Perfect. Great updates in the chat. Really loving everyone's responses on why we needed to update the route table. We're all geniuses, aren't we? Wow, look at that. Yeah. Great point, Supriyo. You've caught that we needed to change the CIDR block when we're setting up the route table. Ehab says done. Great job, Ehab, for setting up, for editing your route table. Murat says, if the route table is not updated, traffic goes over the internet. Is it correct? Yes, that's correct. So to be more specific, if the route table is not updated, traffic from one VPC getting to another VPC would still go through the internet. And we can also mention that it's like through the public internet. So very, very great response there, Murat. Okay, we're going to click done because we have just written some amazing answers. And before we move on, just remember that I think we haven't written this explanation at the start. So we're going to just make sure that we have also written a quick, I'll say a brief one-sentence recap of what this step is about. So what are we doing in this step? In your own words, explain what you're doing here. We are editing the route tables for VPC1 and VPC2 so that traffic can be directed to the peering connection. Jong says need to head out. Oh, you did the dab as well. Jong, it's so good to see you here. Jong, thanks for being here. And a big shout out to you, Jong. It's so good to have you here. And so sad you need to head out, but hope to see you in the next live. Wow. Jong, it's so cool. It's so cool that we're still hanging out together every single Thursday doing YouTube lives. To everyone that hasn't met Jong yet, Jong was the very first person to ever attend a YouTube live with Nextwork, ever since the very first project about hosting a website on an S3 bucket. So thank you, Jong, for being here, and hope to see you in the next one too. All right, so in this step, we were editing the route table for VPC1 and VPC2 so that traffic can be directed to the peering connection set up. Cool. Click done. All right, so in the next step, we're going to be launching a few EC2 instances. Spicy. We have launched EC2 instances before in a VPC. We're going to do it again, and we're going to learn a few new things while we do it this time. Joe says, what a legend. Jong is absolutely a legend, Joe. I have to agree with you. Shout out to Joe, too. Joe, you're so sweet. Thank you so much. Joe is absolutely an OG, by the way, to everyone that hasn't met Joe as well. Joe has been learning with Nextwork since November last year as one of the very first students learning AWS with us. It was because of Joe's feedback, Joe being in our beta cohort when we were still testing out how we could teach AWS, that we have learned that hands-on projects are very, very valuable. So a big shout out to Joe for being such a legend in this community too. Okay, in this step, launching EC2 instances, we're going to be launching an EC2 instance in each VPC so we can use them later to test the VPC peering connection. So what are we doing? We are launching an EC2 instance in each of the VPCs, VPC1 and VPC2, in each of the VPCs, VPC1 and VPC2, so that we can directly connect with an EC2 instance. So we can directly connect with our instances later and test our VPC peering connection. Looks good. I think that's great. And let us click done. Awesome. Do you remember how to launch an instance in your VPC? I hope we can do this together again in a very smooth fashion since we've done this before. But if you don't remember how to do that, that's okay. We're still going to be doing it all step by step together. First things first, we're going to search for EC2 at the search bar at the top of our AWS console. Okay, EC2 over here. We're going to click on EC2 and select instances in the left-hand navigation panel. Nice. Once we're here, we're going to select launch instances like this. And we're going to set up an EC2 instance just like that. So the name is going to be instance Nextwork VPC1. And for the Amazon machine image, this right here, we're going to be using a free tier eligible one. Make sure whichever one you select, it says free tier eligible over here. And then we're going to select for the instance type t2.micro right here. Again, make sure it's free tier eligible, by the way. Okay, now next step. For the key pair login, which key pair are we going to be using? Plot twist, everyone. For the key pair, select proceed without a key pair. Now, last two projects, we said it was so important to have a key pair because it helps you with directly connecting with an EC2 instance. But we're gonna need to remember for this project that how do we actually directly connect to that EC2 instance? We directly connect to that EC2 instance by using a tool called EC2 Instance Connect. And this tool creates key pairs and manages it for us. So what that means is when you actually create the EC2 instance, you don't actually need a key pair. EC2 Instance Connect, which we're going to use in a second, is going to do all of that for you. So we're going to be a bit more slick in the way we set up our instance today by saying we don't actually need a key pair since, well, Instance Connect is going to be doing that for us. And for our network settings, let us make sure that we are editing our network settings so that the VPC this EC2 instance is being launched in is Nextwork 1 VPC that you've set up. Okay, and you're using the public subnet, and we're going to keep all of these settings over here, and we're going to select the existing security group. since our VPC has already created a security group for us, let us just use that. And we're going to select launch instances right here. Cool. We're launching the instance now, and it's done. In a second, we've created a virtual computer. Man, that always stuns me. That's always just such a magical feeling. Like, just like that, in an instant, you've created an instance. Okay, so do you think you can set up an EC2 instance in VPC2? Can we do that together? Let's see if we can beat my time. Again, launch an instance. For the name, this time it's going to be instance Network VPC2. Select the free tier Amazon Linux machine image, the free tier instance type, key pair login. Do we need one? No, we don't. EC2 Instance Connect really takes care of everything for us. Network settings. This time is going to be in our second VPC. Make sure it's in the public subnet. And then let's select the existing security group since it's already been one created for us by Amazon VPC. And then we're going to keep scrolling down and we're going to launch the instance. That was 1 minute. I swear that was probably just 1 minute. How long did it take you? How long did it take you to create your second EC2 instance? I am very, very curious. Okay, let's keep going. King of Zamunda says, hello, Natasha. Feeling great to be here. Ooh, King of Zamunda. We are so happy that you're here too. Ehab says, I'm already on it. Ehab, you're a legend, aren't you? All right, so why did you choose not to set up key pairs? Do you remember this? The answer for this is, I didn't set up key pairs for these EC2 instances as... Oh, Ehab says done. You are a legend. You are a king, man. That's so cool. Congrats on launching your second EC2 instance already. That was very fast. Very, very proud. You should be very proud of yourself. We didn't set up key pairs for these EC2 instances because we are using EC2 Instance Connect to directly connect with our EC2 instance. Later in this project. Which handles key pair creation and management for us. So if we weren't using EC2 Instance Connect, that means we would have had to create the key pairs. But because we are using EC2 Instance Connect, that's already going to be taken care of for us. So let's click done. We don't need to create those key pairs. And let's start connecting to instance 1. We've created 2 EC2 instances now. So can we try to connect to instance 1? Do you remember what it means to connect to an EC2 instance? This is actually quite an important thing to understand because why do we connect to instances in the first place? The reason for connecting to an EC2 instance is so that you can directly use the terminal of that EC2 instance to install things, to configure your computer, to configure your server, and to do some advanced things that you might not be able to do in the management console. I can tell you now that trying to set up a connectivity test just using the AWS management console, I would actually not know how to do that because you need to connect to an EC2 instance in order to be doing things like sending a ping message, or in order to be able to read some important messages or responses in a computer in an EC2 instance's terminal, and that's why connecting to them is so important. A lot of the time you can use your management console to do things to your EC2 instance. For example, you can host a web app on your EC2 instance without needing to connect directly into that EC2 instance. But absolutely, if you want to be seeing some important things like literally going into that instance so they can try to connect with another one, absolutely, you're going to need to connect to this EC2 instance that you're trying to go into in the first place. I feel like connecting to an instance is absolutely just a key skill to have as a cloud engineer. So a very, very good skill to be building as well. All right. So in this step, we're going to be using instance connect to try connect to that first EC2 instance. And then we're going to fix a connection error as well. So what are we doing in this step? We are using EC2 instance connect to connect directly with our first EC2 instance. We need to do this because we need to use our EC2 instance for connectivity tests later in this project. Cool, I hope that was clear. So we are using EC2 instance connect in this step to connect directly with that first EC2 instance. And the reason for doing this is so that we can use that EC2 instance to run connectivity tests later in this project. And you can ask yourself, why are we running connectivity tests? We're running that to validate our VPC peering setup. How do you know you've set up your VPC peering connection correctly if you don't test it? That's the entire reason for creating this EC2 instance and later on running those connectivity tests. Okay, done. So let us do some connecting to an EC2 instance. We're going to click on instances in our AWS Management Console, and then we're going to click on instance next to VPC 1. Okay. And then we're going to select connect over here. Oh no, that's an error, isn't it? Look at that. The error here is saying there's no public IPv4 address assigned to your server. You might also notice that there's another error over here. It says EC2 instance connect service IP addresses are not authorized. Port 22 is authorized in your security group, but to use EC2 instance connect, it is recommended to also authorize port 22 for the EC2 instance connect service IP addresses in your region. All right, let's sort this out all together. So we have two errors while trying to connect to our EC2 instance. One is a port in your security group, and then the other one is the IPv4 address that's assigned to your instance. Now, let's focus on this error. Let's ignore that top one for now. Let's focus on this bottom one and talk about it. This error message is trying to say that you can't use EC2 Instance Connect if you don't have an IPv4 address for your EC2 instance. What that means is we don't have an IPv4 address for our EC2 instance. And do you remember why this happened? How is it that one of our servers in a public subnet, how does it not have an IPv4 public address? Well, when did we do this? We did this when we first set up our EC2 instance, and there was this setting that said auto assign public IP and we kept it as disable when we set up our EC2 instance. So that has essentially caused this error. Leaving this setting, auto assign public IP as disable, essentially caused the error that we're seeing now, that there's no public IPv4 address assigned and we can't use EC2 instance connect. So what we're going to do now is first take away this key learning. We're going to remember, okay, we are learning now that if you want to connect to your instance over EC2 instance connect, your instance must have a public IP address and be in a public subnet. This is because EC2 instance connect connects to your server over the internet by default. So this tool that we're using, there's us using the AWS Management Console. We're using on the AWS Management Console EC2 Instance Connect, which uses the public internet in order to connect to your EC2 instance. So if your EC2 instance doesn't have a public IP address, it can use the public internet, but it can't actually find you. It can't find your server because you absolutely need a public IPv4 address in order to be findable or searchable or accessible over the public internet. So let's solve this issue. Let's take a screenshot of our EC2 Instance Connect page, which is showing the yellow error banner. And let's do this. Cool. All right, let us upload this here. Aha, Murat has asked a good question. Didn't you enable public IP for EC2? How do you establish SSH? How do you establish SSH connection or security group allow SSH or ping? Yeah, Murat, we're going to be addressing each of that later in this project, but great shout. Love that you're already thinking about this. You're already like 5 steps ahead. Supriyo says, need to create an exception for port 22. Yeah, you're noticing the top one, aren't you, Supriyo? We'll be doing that too. In the meantime, we're going to focus on this error first. Let's make sure this error is resolved, and then we'll tackle the other one. Thank you, Supriya. Okay, so, alrighty, just 1 second. We're going to just make sure that we have done everything as we have expected. Yes, yes, yes. We have answered all of the tasks so we can safely move on. Let's click done here since we've uploaded the screenshot. And then we're gonna head back to the instances tab, okay? And you're gonna notice for Network VPC 1, is there a public IPv4 address? Dun dun dun, it's empty. This field is empty. There's no public IPv4 address, so the error from Instance Connect is absolutely valid. On your EC2 console's left-hand navigation panel, we're going to select on Elastic IPs, which you can find under Network and Security. So click on Elastic IPs over here, and we're going to be selecting something called Allocate Elastic IP Address. So, quick pause. What are Elastic IPs? What is this page? It's a very new page. We've never been here before, so welcome. Elastic IPs are static IP addresses that you get to allocate, that get allocated to your account, and it's yours to delegate to an EC2 instance. So you know how whenever we create an EC2 instance, we'll just be like, oh, enable auto-assign public IP, usually. You know, we enable it, and now there's an IP address magically just created for our EC2 instance. IP addresses work slightly differently. IP addresses, how these work, is instead of an IP address getting assigned to your EC2 instance the moment you create one, Elastic IP addresses is an IP address you're basically just requesting from AWS and say, hey AWS, I might not have a resource that I've just created, but can you just give me an IP address for me to hold on to? Just give that IP address to me, and once I have it, I'm gonna keep this IP address in my account, and when I do have resources that I want to get a public IPv4 address, I'll give it to them. That's how Elastic IP addresses work. An important thing to note is that these elastic IP addresses are always public IP addresses. So you're not asking AWS for a private address. You're asking AWS for some public IP addresses, and AWS is going to give them to you, once they're allocated to you. And then with this, with this entire page of IP addresses that you can set up, you can be like, you get a public IP address. You get a public IP address. You get a public IP address. So that's how elastic IP addresses work. Now, the reason why this exists, we're going to be using it so that we can give our EC2 instance a public IP address. That's why we're using this page today. But there's actually many different use cases for elastic IP addresses. One of the use cases is the fact that elastic IP addresses help specific resources in your VPC to always have the same IP address to keep it consistent. Because usually an IP address, the public IP address for a resource can change all the time in your network. So for an EC2 instance, an IP address, the public IP address for an EC2 instance can change every time you reboot or restart your EC2 instance. It can be like, shut down EC2 instance, start it up again. And the moment you start it up again, it can start up with a completely different public IP address. This can be a problem if you want your resource to be accessible over the internet, and two things can happen. A resource that has manually hard-coded a public IP address would be like, oh no, I can't find your resource anymore. You've changed addresses. You've changed public IPv4 addresses. I can't find you anymore. Another potential issue is the fact that websites, for example, nextwork.org, at the end of the day, when you type in nextwork.org in your browser, what it does is nextwork.org points you to an actual IPv4 address that is the server that is hosting your website or your application. So what happens if you change IPv4 addresses for your resource? What's going to happen is the web server that was hosting your website, it's going to change IPv4 address, and it's going to now say, hello to a system called DNS, which is the map that points nextwork.org to the right server. It's going to say, hello, DNS record. Can you please update yourself so that you're now saying my new IPv4 address? Your DNS record can update, but then the actual process of mapping you to the right IP address can actually take hours or even days. So websites can actually end up going down, just inaccessible to all the users in the time that your DNS record is being updated. So what that really means is if you have an elastic IP address, this one that you've allocated to your account, once you give that IP address to an EC2 instance, they're going to always have the elastic IP address. Now, when you shut it down and reboot it, shut it down and start it back up, your EC2 instance will always still have the same IP address, so that all of those issues we just talked about won't happen anymore. Cool. So I hope that was clear on why elastic IP addresses exist. And we're going to be creating one just so that our EC2 instance can have a public IP address too. Cool. So we're going to click on allocate elastic IP address, and then we're going to take a screenshot of the elastic IP address setup page. So we're going to take a screenshot right now. I would say something like this is perfect. And we're going to drag that screenshot into our step-by-step guide so that it can collect that screenshot for us. And then we're going to click done. Perfect. Murat says perfect explanation. For real, Murat? Thanks. That's awesome. That's awesome. Really glad to hear that explanation was helpful. Okay, so we've taken a screenshot of it. And now let's try to understand this setting. So what we've just opened up here is a page to allocate an elastic IP address. So here, this very first setting is basically AWS saying, okay, I hear you. You want to request a public IPv4 address into your account so you can delegate it to another resource later on. Okay, I hear you. where do you want that public IPv4 address to come from? Because at the end of the day, don't forget that public IPv4 addresses also come from this pool of all the IPv4 addresses in the world. Public IPv4 addresses aren't infinite. There's actually a limited number of public addresses. And like we've said before, we don't want resources to have the exact same public address because it could mean that route tables route you to the wrong resource. So what that means is the public IPv4 address that we're going to get needs to be completely unique in the world of the public internet. So where is that public address going to come from? The first option is Amazon's pool of IPv4 addresses, and that's what we're going to be using. So think of Amazon's pool of IPv4 address as this huge public pool or this huge basket of IPv4 addresses, public IPv4 addresses that Amazon has gone out into the internet and collected and saved into this big bucket so that it can allocate to AWS accounts or AWS users that wants a public IP address. You can imagine that this is a huge pool. Heaps and heaps and heaps and heaps of IPv4 addresses in this huge bucket. And then what we're simply doing is we're requesting for one of those addresses from Amazon's big bucket. We just want one. We just want to take one out. There are other options. Amazon is not the only player in the public internet space that can have IPv4 addresses, public IPv4 addresses. Many other people do. You can even bring your own IP. And those are the two other options. If you somehow owned a public IPv4 address already, you can bring that into your AWS account and use that IP address that you own yourself. But for us, we don't really own an IP address. We don't really own something like that yet. So we're just going to be using Amazon's pool of IPv4 addresses. We're going to be taking one from there. And absolutely, the network border group is something that you can just click on. It's just going to be your region. And then just like that, you can just allocate your IPv4 address right away. Okay, so refresh your page. You can use that handy refresh button over here. And then you can select your IP address. So select that. And under actions, we're going to associate this IP address. So associating basically just means you now have an public IP address that's sitting in your account now. It's saying, hi, I have an IP address. Users from the public internet or the public internet can reach me, but I am not connected with any of your resources right now. So it's almost like people from the internet can reach this IP address, but this IP address is taking them nowhere. You're going to need to associate it. So we're going to click on associate. And then we're going to say, oh yeah, this IP address we're going to associate you with an EC2 instance. So under instance, we're going to click on Network VPC 1, and we're going to click on, we don't need this private IP address thing. We'll just leave it blank. And then we're going to click associate. But just in case you were curious, if you're wondering why we didn't need to click here, this selection will only be important if we had a single EC2 instance with multiple private addresses, which is totally possible. You could have one single EC2 instance and multiple private IP addresses that it owns. And you would have this multiple IP address set up if your one single EC2 instance was hosting multiple applications. For us, it's not. So we don't need to select this, but we would have needed to select something here if we had a more complicated EC2 instance setup. But yeah, we're ready. Just click on associate. And if you click on into instances again, you're going to refresh your instances page. Wow, would you look at that? Check out the public IPv4 address section of your EC2 instance. Do you see how there's already a public address in here now? So cool. And the Easter egg is remember your IP address number. For us it's 54.69.47.151. And then click here back to your Elastic IPs page, aha, it's the exact same IP address. So that means we've successfully allocated this public IPv4 address we've taken from Amazon, and we've now given it to our EC2 instance. So success. Well done. Let us try. Oh, okay. Let's answer this question now. Next, I use EC2 instance to, we were trying to use EC2 instance connect to directly connect with EC2 instance with instance network VPC1, just by using the AWS management console. Next question. What was the error we ran into? Do you remember that yellow banner we saw? We were stopped from using EC2 Instance Connect. That's correct. That did happen. We were stopped from using EC2 Instance Connect as our instance did not have a public IPv4 address. In order for EC2 Instance Connect to work, the EC2 instance must have a public IPv4 address and be in a public subnet. So to resolve this error, I set up elastic IP addresses. Elastic IP addresses are, what are they? Let's explain this for a little bit. To resolve this error, we set up elastic IP addresses, and they are public static, public IPv4 addresses, that we can request for our AWS account and then delegate to specific resources that will use this IP address I will just keep this concise and just say, and then delegate to specific resources. Done. Next question. Associating an elastic IP address resolved the error because it gives our EC2 instance a public IP address, fulfilling all the requirements for Instance Connect to work. For Instance Connect to work. Once that's done, we're going to click done. Once that's done, we're going to click done. Task completed. All right. We are going to be clicking on connect one more time. And there is another issue over here, isn't there? So apologies, team, that this issue isn't being mentioned in your step-by-step guide. But we absolutely need to use the correct port and have that in our security group too. So we're going to address this by, we're going to address this by first clicking on connect. Boom. That was a long intermission time. I wasn't expecting it to take so long to load. But yes, we have failed to connect to the EC2 instance. You know what? We have seen the exact same error in the previous project. Do you remember how we resolved that error in the last project? Do you think you can use those steps right away and do it yourself? Let us see. I'll be doing this step by step. In the meantime, if you're feeling brave, you can pause this if you'd like and attempt to resolve this error by yourself, especially if you've done the previous project and you've done it before, because the step to resolving this error is exactly the same. Exactly the same. So absolutely give that a go if you'd like. Okay, in this step, you're going to use EC2 Instance Connect to connect to the instance one more time and fix another error. Yes, this error that's right in front of us right now. So what are we doing in this step? We are reattempting our connection to instance Network VPC1 and resolving the security group, resolving another error, preventing us from using EC2 Instance Connect to directly connect with the instance. All right, so that was exactly what we're going to be doing now. And let's click done one more time. Task completed. Amazing work. So we have failed to connect to the instance. Again, do you remember how to resolve this error yourself? You're absolutely welcome to pause this, what is this called? Pause this live project demo to try resolve this on your own. All right. In the meantime, if you'd like to follow along, we're going to be going back to the VPC console. So let's type VPC over here. Let's right click. Let's go into it. And let's select subnets from the left-hand navigation panel. Let's select subnets. It's over here. And then let us select your subnet, which is public 1 subnet. And then let's drag it up. And let's take a look. Look at the route tables. All right, the route tables are looking good. Network ACLs. Looks good. All traffic is looking good inbound and outbound, because all traffic is allowed. So there's no way this could be stopping us from using EC2 Instance Connect. But, if you look at this error here, it's saying ensure your instance network settings are configured correctly. So there's definitely a network issue happening here. We need to fix the network setup in order to fix this connection issue. And we've just said that technically our network ACLs are looking good because all traffic is allowed into your EC2 instance. So what could be the issue? You've all been very, very spot on in the chat by mentioning security group. So let us go into security groups. And let us select the security group that's associated with your EC2 instance. Now, one pet peeve I have about security groups is that their names are always just so hard to identify. Like, how do you know which one of the 3 is a security group for your EC2 instance? Can you just tell from a glance? I know I can't. I find this really tricky. But one way you can find out is by clicking into the VPC ID of these security groups and then identifying which one is connected with Network 1 VPC. So we know the first one we just clicked, which is not correct, is connected to Network 2 VPC. So let's head back. Let's select the second one. This one is connected with Network 1 VPC. So the second security group over here is the right one. So we want to be using this one. And then we're going to be looking at the inbound rules tab over here. And yeah, the inbound rules tab is telling us that all traffic, all types of traffic is allowed. Does that look right to you? Is there one thing that sticks out to you about this inbound rules tab? So it is a great thing that the inbound rules allow all kinds of traffic. The traffic that's going to come from EC2 Instance Connect is called SSH. That's the kind of traffic that's going to be getting to our EC2 instance. But notice how the source here is not very, very open to everything. The source is the security group. So if you click onto here, click into the source and just have a look. If you were to click into this, it loops us back to our security group, the default security group that's set up for our VPC. That's honestly, alarm bells are going off right now, because what this means for us is only traffic coming from the security group is allowed. Okay? Because all types of traffic are allowed, but where is this traffic coming from? It's only allowing in traffic that's coming from the security group itself. So what that means is traffic that's coming from EC2 Instance Connect, which is using the public internet, is not allowed in because it doesn't fall into this source field. My goodness, such a small detail, but it makes such a big impact. We can't even connect to our EC2 instance because the security group says, this traffic isn't coming from my own security group, so I'm not going to let you in. Wow. We want to make sure that EC2 Instance Connect can get to our EC2 instance, and it uses the public internet. So let's edit our inbound rules. And let us add a new rule that says, hey, great rules going on over here. It's pretty strict though. We're going to also let in SSH traffic that's coming in from EC2 Instance Connect. And to make it very easy for us, we're going to just say all sources. So 0.0.0.0/0 means all IP addresses, all public IP addresses in the public internet can now have permissions to access your instance using SSH. So absolutely, that means the IP address that EC2 Instance Connect is going to be using is also allowed in. So perfect, we're going to save the rules. Okay, and then we're going to reattempt this connection. So we're going to go into, we're going to click into Network VPC 1, and we're going to click on the connect one more time. Oh, this error is still here. Did we save that properly? I hope we did. If we haven't, we'll just retry this. Oopsies. Okay, that worked. And I just dropped my pen. Sorry, 1 second. I'm gonna quickly grab my pen. That is not the first time that that is not the first time that an excited moment makes me drop my pen. I remember in a previous live project demo, an excited moment made me like drop an entire coaster for my cup, and that was a pretty embarrassing moment as well. But we've had a success, everyone, so congratulations. Do you see how you can connect to your EC2 instance now? That was amazing. So just by updating your security group and making sure that it also lets in SSH traffic for all kinds of IP addresses, including the IP address that EC2 Instance Connect is going to be using, you're now able to directly connect to your EC2 instance. So congratulations, you're all connected now. And if you were able to do that without any guidance, because it does follow very similar steps to our last project, extra kudos to you for doing that. Okay, so we're now on to the final step of today's project, which is to now test VPC peering. So don't forget, the entire reason of creating an EC2 instance and trying to connect to it is so that we can test whether the peering connection we've set up, whether that bridge that we've built between our two VPCs is actually a functioning bridge. Does it actually directly connect two VPCs? Does it actually allow them to communicate without the public internet? We shall find out. So when we are testing VPC peering, we're going to be doing this by using a connectivity test. And we've learned all about connectivity tests in the last project, so I highly recommend checking out the previous one if you're new to it. But the steps for running that is actually very, very similar. So this step is going to look a bit similar to you as well if you've done the previous project. Cool. So what are we doing in this step? Let us explain that one more time. So in this step, we're going to use the instance in Network VPC 1 to attempt a direct connection with Network VPC 2, Network VPC 2, with the instance in Network VPC 2. So we're going to attempt a direct connection with the instance in Network VPC 2 so that we can validate that our peering connection is set up properly. My goodness, the things we do to validate our network setups. Let us click on done. Task completed. I think we're ready to get started. Okay. A big shout out to everyone, by the way, in the chat. Thank you, Abdul Rahman. Abdul says Natasha is just so cool with her explanation, guys. Understanding her with ease. Thank you, Abdul. That is so, so sweet. It makes our day to get such excited feedback like this. Ehab says, agreed. Wow, thanks, Ehab. Shubham says, can you share your LinkedIn profile? Oh, absolutely, we could. I wish I could show you my LinkedIn profile right now. I'll show you that in a minute. Thank you, Shubham. Okay, so let us use this diagram. Just take a second to take it in. Look at the connection. You're going to be going all the way from instance in Network VPC 1 and go all the way to the instance in Network VPC 2. So this is going to be quite exciting. Okay, I'm going to give you another moment to just take in this diagram, understand what we're going to be doing. Alrighty, so we're now going to head into the step by leaving open this page. So we have this EC2 instance connect page working now. We're going to keep this tab, okay? We did the hard work of making it work. We're not going to leave this, we're not going to quit this tab so quickly, but we are going to be in a new tab. Head back to your instances page and let us find the private IP address of our EC2 instance. So let us find the private IP address. You can find it right here. And let's copy that. And do you remember what was the command we used in order to set up a connectivity test with another EC2 instance? Do you remember this specific command from our last project? All right, that specific command was ping. So we're going to go into here and we're going to type in ping, paste that, run it. Ooh. So if you recall, ping is a tool to test the connectivity and really test the health of a connection between two servers. How ping works is ping, when you enter something like ping 10.2.0.0/.129, what you're really doing is you're sending traffic from your EC2 instance to the other EC2 instance with this specific private address. You're saying, all right, ping, we're going to send this message over to this other EC2 instance. How you will know that ping has been successful is when you see lines and lines and lines and lines of feedback. When you get all of these lines, that is basically the other EC2 instance that you're sent that message to, saying like, I hear you, I hear you, I hear you, I hear you. This is just validation that your connection has been set up properly. Look at what we see though. we see just one sad line. Our one sad line just says ping our second EC2 instance's IP address, and we've just sent it this much data. So what we're seeing right now in the terminal is just some sort of confirmation that, oh yeah, our EC2 instance, EC2 instance 1, has sent out a data packet. It's just this message has gone out. But we are not seeing any replies. We are not seeing anything from the other EC2 instance to say, I've heard you, I hear you, I see you, we're connected. We're not getting any of that right now. So this actually isn't a very good or healthy response, for running ping. This means there is a connectivity issue. Okay, so we've talked about this last time, how to resolve this. Do you think you can resolve this yourself? If you can, again, pause this video right now, and have a go at trying to resolve this error by yourself. All right, in the meantime, of course, we're going to be doing this step by step together. So we are going to head into our security groups page over here. And again, if you'd like, you can click into your subnets and click into your second instance's subnet to just check, how is it set up? Is it set up okay? The route tables look okay. It is allowing in traffic from the other VPC. It is saying the traffic from the other VPC can just come in, through this peering connection. And there's also a network ACL that allows all kinds of traffic. Traffic is being allowed in. So what is the network setup issue that we have here? It always comes back to the security group, doesn't it? So when you check your EC2 instance 2's security group, have a look at the inbound rules. All right. All traffic coming from within the IPv, all kinds of traffic coming from within the security group is allowed. Done. Oh, is this the right? Oh, I don't think I'm selecting the right security group here. I should be selecting the one below. Again, you can always test by just clicking on the VPC ID. Here I can see, it's the second one now in the list that's connected with NextCirc 2 VPC. So when you look at the inbound rules, you're going to see that all kinds of traffic from within the security group is allowed. Perfect. Great. Healthy. But you're going to notice again, hey, the traffic that is coming from not within the security group, but from our other VPC is not being allowed in. There is no rule that says traffic from the other VPC is also allowed into the security group. So absolutely, because of that, your second EC2 instance is not going to be receiving any of the traffic that's coming from your other VPC. Let us change that. So we are going to edit our inbound rules, and we're going to add a rule. The type for this is going to be ICMP, correct? All ICMP. And then, can you remember what the source is going to be? What do you think should be the source of our ICMP traffic? What kind of CIDR block or what kind of range should we be entering here? All right, so the range that we should be entering is the CIDR block of VPC1. So we can just copy that here from the guide and paste that here. So what that means is all kinds of ICMP traffic coming from our VPC, from the other VPC, VPC1, is allowed into your EC2 instance 2. Now, someone in the chat might be asking, I'm going to check, has anyone asked that yet? No, we haven't had anyone ask that question yet. But often, you will be able to narrow this down so that it's not only just the specific, this entire VPC. It can be the subnet. It can be the public subnet, only ICMP traffic coming from the public subnet. It could even be only ICMP traffic coming from the specific EC2 instance. It can be that specific. For now, we're just going to keep things simple by making it very, very broad. And then we're going to click on Save Rules. All right. All right. Bushan says, I don't know why I'm not getting docs, which you are now showing. When I'm logging through web or from app, only getting link for YouTube video. Oh, really? Oh, no. Link for documents which you are showing on this side. I hope you're able to find the project guide. Thank you so much. Thank you so much for letting us know. Let me try to give you access, Bushan. I'm gonna add this to the chat now. Can you please check, Bushan, if that link works for you to give you access to the project guide? I really hope it does. If it doesn't, let us know, and we'll try to resolve that right away. Okay, I think we're still now all ready to revisit the EC2 Instance Connect tab. Oh, I'm gonna make sure this is all okay. Whoa! Wild, isn't it? Isn't it just so wild? Just now, we were saying we only had one sad line of feedback. Look at all of this now. How cool is this? We have so many replies coming back to our EC2 instance. Because don't forget, what we're seeing is things that the EC2 instance in VPC1 is seeing. What we were editing just now was the security group for our EC2 instance in VPC2. So we were actually looking at things from two different VPCs, but they're now connected, okay? And this wouldn't exist if your peering connection wasn't set up. This wouldn't happen if your security group wasn't set up. This wouldn't happen if your server didn't have a public IPv4 address to let us connect to it over EC2 Instance Connect. So many things, so many intertwined steps, or so many things have to work well just so that we can see these responses. Isn't that just amazing? Like the things that we do in order to see the things that go behind things that might look simple, in front of us. That was amazing. So a big congratulations to you if you can see these responses, because that is absolutely success for us. That is absolutely the success that we want to see. So amazing. The multiple new lines are a sign of that successful communication between the two EC2 instances, and they're doing this across VPCs. So that is amazing. Congratulations again. And we shall wrap this up for today's project. Before we wrap it up, though, I see some more comments in the chat, so let's talk about it. Okay, Bushan says, yes, I'm only getting this. Oh, Bushan, I'm very sorry that the link still only takes you to the YouTube. Can you please confirm again in the chat that the link we just sent you in the chat is still taking you back to the YouTube video? That would be quite concerning, actually. If it only takes you to the YouTube video and not the step-by-step guide, let us know. All right. Joe says, ping is looking good, ma'am. Thank you, Joe. I think it's looking pretty good, too. Holly says, hi, Holly, by the way. I think this is your very first message in this entire chat. So it is very good to have you here, Holly. Holly asks, will it work now if we do it from VPC 2 to VPC 1? Good question. Or do we need to update the security group first? Good question. Yeah, so don't forget that for VPC 1, what were the steps that we needed to take in order to make this happen? First, we needed to give our EC2 instance a public IP address, and then we needed to set up the security group that allowed an SSH traffic from EC2 Instance Connect. And then after that, in this step, we also needed to change the security group for the other VPC so that it's allowing ICMP traffic. So that was absolutely like 3 things that we needed to do in order to make it work. But absolutely once that all of that is set up, you will be able to get traffic flowing the other way around too, from EC2 from VPC2 to VPC1. But yeah, Holly, it's so good to have you here. This is really, really cool. If I'm not wrong, I think you're also in the Nextdoor community as well, unless I'm speaking to a different Holly right now. But yeah, big welcome to your very first live. Ehab is giving us the meteor or like the pow reaction because that was fantastic. Aha! Bushan says, if possible, can you show how to access this doc from project? I'm still only getting project name 5VPC link. Bushan, you have asked a very interesting question here. So do you see this project at all when you visit this link that we sent to you in the chat? What you could do is you can click on, if you get to this page, you can click on my projects over here, and then you can click on VPC peering from the left hand navigation panel. If you still can't seem to access the project guides through the links, can you give this a go, opening a new tab and just typing in nextwork.org in that new tab. And then when you get to nextwork.org, use that bottom bar here to get to VPC peering. I hope that works for you. Let us know, Bushan. I'm sending you good vibes. I'm sending you good energy. If you still don't see it, don't give up. We're going to find that project for you. Okay. Very, very cool. We have more questions in the chat. Jerome says, can we trace the route from VPC1 to VPC2? Yes, you can. We can trace the route. Are you wanting to, by tracing the route, do you mean you're wanting to see almost like a map? Because we can absolutely, use the architecture diagrams that we've drawn to show that tracing. There's also something called VPC flow logs or monitoring, which we're going to do in one of the next projects. I think in the one right after this, where you can actually see logs that trace the activity going on between 2 VPCs. So that one is really, really cool. And Holly and Joe, thank you so much for the good vibes. Joe says, welcome, Holly. Good to see you here. Enjoy the vibes and great energy. Thanks, Joe. Holly says, thanks, Joe. Definitely loving the vibe here. And thanks, Nat, for the explanation. Of course, Holly. Absolutely. Holly, was that explanation okay? Let us know if you'd like more details. We can absolutely just keep on talking about this. Shubham says, I am new to cloud and it looks interesting. Woo! Go Shubham! I think cloud is super interesting. Everyone in the community is going to agree with you there that the cloud is interesting, that there's a lot of cool stuff happening here. How to join the Nextdoor community? Oh, very good question. To join the community, all you have to do, Shubham, is to use community.nextwork.org. I hope that link works for you. Let us know if not. But yes, give that link a go, and you should be able to access us. Okay. So cool. And Andre says thank you as always. Thank you so much, Andre. Thank you for being here, and thank you for the good energy. Okay, so wow, look at this. Our ping replies have been popping off. We're now at message number 884. Wow, that is just amazing. So we're going to take a screenshot of this healthy response coming through from our second EC2 instance. And let's put that screenshot into our step-by-step guide. Cool. So once that's done, we're going to answer a few questions. What was the command you ran to test VPC peering? To test VPC peering, I ran the command ping 10.2.1 point xxx point xxx. We don't really need to know the details of the other, we don't need to know the details of the other, what is it called? The other EC2 instances private IP address. We just need to make it very, very clear that it starts with 10.2. And then we're going to make it very clear that this is the private IPv4 address of the other EC2 instance in VPC2. Cool. I'm going to click next here. And it says, how does a ping test validate your VPC peering? So a successful ping test would validate my VPC peering connection because this ping test would not get any replies from the other EC2 instance if the peering connection did not successfully connect our two VPCs. In other words, getting ping replies equals VPC equals peering connection. Oh, okay. I ran over the character limit once again, but we really just need to say a successful ping test would validate my VPC peering connection because this ping test would not get any replies from the other VPC, from the other EC2 instance, if the connection did not connect our two VPCs. Getting ping replies equals peering connection was set up properly. That's the baseline there. Bottom line, getting ping replies means your peering connection was set up well. Done. Next, how did you update your instance's security group inbound rules? So let's say that I had to update my second EC2 instance's security group because I added a new rule that I had to update my second EC2 instance's security group because it was not letting in ICMP traffic, which is the traffic type of a ping message. I added a new rule that allows ICMP traffic coming in from any resource in VPC2. Alright, actually, apologies. We did this project together, so I'm changing all of this to we. So we did this and we added the new rule together. Alright, perfect. I think to test VPC peering, we ran the command. All done. That was amazing. Let's click done, which validates that we're all finished with the main part of today's project. So congratulations, and let us talk about the rest. So another AWS server is done. What is Amazon VPC? And why is it useful? So Amazon VPC is AWS's foundational networking service. Nice. That lets us create our own networks. Control traffic flow and security. And what else does a VPC do? And organize our resources into public-private subnets. So how did you use Amazon VPC in today's project? Ooh, we used Amazon VPC to set up a multi-VPC architecture because we set up two VPCs. And, oh, we use MLM VPCs to set up a multi-VPC architecture. We also used it to create a peering connection. And update security group rules to successfully and update security group rules to run a successful connectivity test to validate our VPC peering setup. Very cool. What is one thing you didn't expect in this project? Oh, I have one. Do you have one? Do you have something that you didn't expect in today's project? I would love to know what was yours. For myself, it was I didn't expect to need an IPv4 to need a public IPv4 address. I didn't expect to need a public IPv4 address to use for EC2 Instance Connect to work. And what was something we didn't expect? Also didn't expect that elastic IPs can assign static IPv4 to resources. That was pretty cool learning. And last bit, how much time does this project take you? This project took us 2.5 hours, including chatting time. That's me being cheeky here. Awesome. So really, really happy with all of these responses here. And we can go ahead and click done. Submit our responses. Very cool. So a big shout out to everyone in the chat here. Thank you so much to Holly saying, yes, your explanation is easy to understand. Let me know how to connect. Absolutely, we can do that through the Nextr community. That's the #1 place. That's where I live, honestly. Other than that, LinkedIn is great too. Supriyo says, thanks for another great session. Please make a session in the future on how to configure MFA authentication for AWS for other platforms. Very interesting project topic. We haven't actually touched on that before. Thank you, Supriyo. We actually do have a wish list of all projects requested by community members, and we're definitely adding this to that. Kyozo says, love you, Natasha, for this project. Sending all the love back, my friend. Thank you for being here for this project. Shrida says, it is really enjoyable session. It was. Oh, thank you, Shrida. Thank you so much. Ehab says, thank you for another project. Very excited to be in the next live session. Same here, Ehab. It has been so much fun with you. You have absolutely crushed today's project, by the way. I hear you every time you're like, done. I created this. I created that. Ehab, you're awesome. Joe says this is always the saddest part when the project ends and we have to say bye to the live. I know. Doing these last few steps always feel bittersweet for me too. Luckily, we still have like 3 more steps to go, technically, outside of this main project part, so we can go through that together. Murat says, very useful lab. Thank you very, very much. We are waiting for the next project. So cool. I'm writing it up as we speak. I'm writing that next project as we speak. Ehab says, yep. Holly says, can we use VPC peering connection for more than 2 VPCs? Chef's kiss question, Holly. I love this question so much. And the answer is that VPC peering connections only exist between 2 VPCs. So when we were setting up that VPC peering connection, shall we just jump there? Yeah, let's do that. So when we were setting up our VPC peering connection, do you see how we could only create one requester? We had to set up one requester, and then we also had to select one acceptor. That was it. There was no way for us to set up multiple acceptors. I mean, if you want, you can say, let us create one peering connection request between two VPCs. Let us create another peering connection request between VPC 1 and VPC 3, another VPC peering connection request between VPC 1 and VPC 4. Like, you can do it that way. You can set up multiple peering connection requests for multiple connections. But you're going to find out really quickly that if you are doing this with a lot of VPCs, it can get pretty curly pretty quickly. So there's actually a tool called a transit gateway that helps us do this in kind of a mass level. So a transit gateway you can think of is kind of like a hub of peering connection requests. It's almost like an airport where like all of the different potential connections just kind of go through a transit gateway. Yeah, it's a very, very cool tool. And Dad of Men says, thank you. You have an amazing style of teaching, very easy to follow. Thank you. Thank you, thank you, thank you. Nextwork itself says, good job, Nat. You are so awesome. I love to see this message from Nextwork. Thank you so much, Nextwork, for the validation. And if you're wondering who could have sent that message, it must have been Maximus using the Nextwork account. True says, what is the next session about? The next session, you are going to be doing an advanced version of a peering connection that also comes with monitoring. So we're going to be doing two things in the next project, a bit more of an advanced peering concept, and then monitoring as well. That one's really cool. Yeah, Maximus says, woo, you're the best, Nat. Maximus, thank you so much, and sending all of that appreciation back to you. Thank you, Maximus. Yeah, as a just as a big shout out to Maximus. Maximus is like one of the biggest supports for me personally, sitting right next to me before every single live project demo. So without that kind of energy, I don't think I'd be able to be so enthusiastic and so happy and excited every single time. Everyone in this community and all of your chat absolutely fuels us to do every single project as well. So thank you. Ehab says, using AWS Transit Gateway to connect more than one VPC, I think. Ehab, you're a legend, bro. That's a top answer. I think you're responding to Holly with that question. So thank you so much, Ehab. Vamsi says, thank you for the amazing project. Waiting for the next one. You're all waiting for the next one already. That was so cool. That's so, so cool. Murat says, next project, VPC traffic monitoring and troubleshooting. Damn, Murat, thanks so much. Thank you so much. That's exactly it. Maybe we will just name it exactly that based on what Murat has suggested. Joe says, oh, surely it wasn't Maximus that sent that message from Nextwork as he used his own account. Joe, you're so cheeky. Shreyan says, hiya. So, so cool. Oh, Maximus. Maximus was trying to be cheeky, but he took it back after the kind words. Pick a side, Maximus. All right. Very, very cool. Thank you so much, everyone, for all the kind words. It is just so cool it is just such a blessing to be doing projects in such a warm and just such a lively community. So thank you all for being here. And let's finish us off in style by deleting our resources. So let's delete the resources by following the steps below. If you'd like, stop your page like this. Stop here so that you can try to delete all the resources by yourself without any guidance. Shall we try to do that? Let's try to do that. So we're going to start by going into our EC2 instances, selecting both, and going terminate instance under the instance state. So once it's done, click terminate. Very nice. It's shutting down straight away. And then we can go straight into our VPCs, click into the VPC, and let us try to, delete the VPC. So shall we delete this VPC? Oh, it says unable to delete. Look at that. You can't delete a VPC until all of the resources inside have been terminated. That's just how important, that's just how big of an impact a VPC has on all the resources inside. you have to make sure all of the instances are deleted before you delete the VPC itself. Now, you might be thinking, hey, we literally just terminated the EC2 instance. And the reason for that is sometimes there is a bit of a lag. So sometimes you do have to actually click refresh like this, and then trying to delete the VPC again afterwards. See, again, it's saying, oh, you can't. There's still another resource to delete. It is the peering connection. Absolutely, we still need to delete the VPC peering connection we've set up. So let us click into peering connections. Let's click into the peering connection we've set up, and under actions, delete it off. We don't need that peering connection anymore. And we must also delete all of the related route table entries since we don't need it anymore. And let's click on delete. Done. So we've deleted the peering connection. It doesn't exist anymore. It's gone now. So let's try delete the VPC again. Do you think it's going to work this time? Let's try. Under actions, let's click on delete VPC one more time. Let's go. Let's go. You can delete it now. So let's click on delete. Adios. Bye-bye, VPC. Thank you for all of your hard work. And we shall now delete VPC 2 as well. Delete VPC. Type delete here. And let's click on delete. Adios to this one again. Bye-bye. Very, very cool. Very, very cool. Knowing that this community is made up of many, many different people from many, many different countries and cultures, I'm also curious, how do you say goodbye in your language? This is just a funny thing. Hopefully we can all say goodbye in different languages as we wrap up this live in a second as well. But if you speak Mandarin, it'll be 再见. If you speak English, it's goodbye. Those are the two that I know for sure. I would love to know how you say goodbye. If you know a language that's not English, that would be very, very fun for us to learn these new phrases together. All right, so we've deleted VPC 1, VPC 2. We've deleted 2 whole instances. Is there anything else we need to delete? We've also deleted the peering connection. Is there anything else? Can you think of it? There is one other thing we've created today. Now, remembering what resources you've created is so important because we need to remember what resources we've created in order to delete everything at the end so we don't get charged. Now, this last resource that we need to delete will charge your account if you don't delete it right away. So let's remember which resource it was, and let's make sure that gets deleted. Now, that resource is in your EC2 console, and it is called, do you remember it? It is called the elastic IP address. Look at that. The elastic IP address, as we remember, is static. It is always allocated to your account. It will always exist. So even after you've deleted your EC2 instance, this elastic IP address stays in your account. Let's make sure we delete that. And let us click on actions and click on release IP address. So let's click on release and let's release it away. Gone. So goodbye to elastic IP address. It's gone now. Yeah, Holly. Really, really great. Holly has said the correct answer. It is the IP address that we needed to delete. And I think with that, we've deleted all of our resources. We've deleted the EC2 instance, the IP address, the peering connections, and then the VPCs. Absolutely wonderful job. Wonderful job. If you really want to, you can also click into each of these pages within your VPC console so that you can refresh the page and you can confirm that all of them have been deleted now. You know, again, route tables. Let's refresh the page. Is it still there? Gone. Absolutely gone. Internet gateways. Are they still there? Gone. Okay, so you can see that once you delete your VPC, a lot of the related resources just get deleted for you. So super, super helpful. You know, same with security groups. Let's finish off these checks by checking our security groups. Yeah, they've all been deleted now, so they're all done. Now, at the very start of this project, we have had people asking, how can you post on LinkedIn? This is how. Let us share everything on LinkedIn by scrolling to the bottom and clicking Mission Accomplished. And then we're going to see a few cool things. Just so that you can see this properly, I'm going to change tabs into the main window so you can see this. Okay, so once you're done with your project and you think you've completed all of the tasks, all you have to do is scroll all the way to the bottom of this page. And then, if you don't have any more tasks to complete, this button will be blue. But for us, we still have tasks to complete. So if you still have tasks to complete, all you have to do is search for the text "return to later" on your screen to jump straight to incomplete tasks. So we're going to copy this. We're going to press Control F or Command F on your keyboard. Okay, and we're going to search for the text "return to later." Aha! We do have one more what is this called, task to complete here. So let us complete this task. Aha! We completely missed this, didn't we? Oh my goodness, we completely missed this. I'm so sorry, everyone. We completely missed this when we were setting up the peering connection. We were a bit too eager, weren't we? And we went straight into the next step. But let us answer a few questions so that we can complete this task for today. All right, a VPC peering connection is a direct connection between two VPCs that bypasses the public internet. VPCs would use peering connections to... why would peering connections exist? VPCs would use peering connections to transfer data in a secure way. Otherwise, VPCs would only be able to communicate over the public internet. Where traffic can be exposed. We don't want that, do we? Next, the difference between a requester and an acceptor in a peering connection is... this is such a good question for revision, isn't it? So what is the difference between a requester and an acceptor? The difference is that the requester in this project, that's VPC 1, initiates the connection, initiates by spelling, initiates the peering connection, while the acceptor in this project, that's VPC 2, accepts the peering connection. Done. Okay, I think that is everything done now. So let's jump back to the bottom of our screen and see if we can actually see our documentation now. Do you see how the button is now mission accomplished? It's no longer gray. It is now blue because we can see because we've completed all the tasks. So well done, you. Click on mission accomplished. Woo! Look at this. Look at this. Look at this. Look at this. Doesn't this look so cool? A celebration from everyone in the Nextwork team over to you. Congratulations on completing the VPC peering project, and here's how you can share it. So you can click on this link at the bottom to download your documentation. Download that. And once that's done, you will see that the download is available to you right away. Just open it up here and look at that. Your peering connection is all set up. Your peering connection documentation is looking beautiful. Look at that. Introducing today's project, how you use Amazon VPC, everything that you've written. You'll notice that emojis currently don't look too good right now once it's in documentation mode, but we are absolutely fixing that right now. This is a fix for this is also underway. Look at this. All the explanations you have for each of your steps, everything that you responded to is right here. This is all of your work. Everything that you've submitted as a response, every screenshot that you've uploaded is now collated into one big documentation. Isn't it just so fun that as you complete validation, as you complete tasks, as you keep on going with this project, at the end you get rewarded with such an amazing piece of documentation that you can take away and share. This looks amazing. Extremely proud of this work. And what we're going to do now is we're going to share it on LinkedIn. Here we go. So all you had to do was click on the share on LinkedIn button and look at this here. You can now get a pre-written LinkedIn post for you that already summarizes your project today. And then you can click on the X button here and click on more, click on add a document, and then you can choose a file and choose the documentation you have created today and give it a title. You can write in your name and say VPC peering like this. Give it a second for this document to upload. Sometimes PDFs do take time. And when that's done, click done. Looks good. Look at that. Your documentation is going to look so good in your post. Chef's kiss. It's going to look so good. And then you can click post. And once you click post, your project is available for the entire world to see. How good is that? So thank you so much for doing this project with me today. That was so much fun. And if you'd like to connect on LinkedIn, absolutely, we definitely can. I would love to connect with each and every one of you. Let us discard this so you can see. My LinkedIn link is simply linkedin.com/in/Natasha-Ong. And we'll be able to connect right away. More importantly, thank you so much for today's project. That is networking project 6 all done. Shout out to everyone in the chat saying, yes, delete the resources. Abhishek says, hey Nat, just amazed with projects. Gangada says, please share this doc. Of course. Of course you can. Oh, when he says, please share this doc, do you mean my documentation that you like to see? The PDF that we've created? Or were you wanting to see just a step-by-step guide? And shout out to Ehab. Thanks, Ehab, for letting me know how to say thank you in Arabic. Is it Ma'al Salama? Also Bay. This is so cool. So would I say Ma'al Salama Bay to say goodbye? I'm so curious. Awai says, thank you for the stream. I'm new to AWS. Woo! Go you, Awais. I'm new to AWS, so I was just observing it for now. Wow. What a great start to your AWS learning journey. You might find that this is pretty advanced because you are actually seeing project 6 in an entire networking series. So would love to see how you find these projects starting from project 1 or another beginner-friendly project in the community. This is super fun. Thank you so much for being here, Awais. And good on you for learning AWS and doing hands-on projects. Okay, so look at this amazing work that you've done today. You created all this from scratch. Isn't that amazing? The key part that we've created today is the VPC peering connection. But other than that, you've absolutely launched all of these by yourself. And you have set up the connections between these components too, which is a very important part. So yeah, today you've learned how to create a VPC peering connection. You've learned how to update your route tables. You've created your VPC peering connection. You've updated the route tables, this one here and the one on top. And then you've learned how to launch and test these EC2 instances to make sure that your peering connection is done well. You've launched this EC2 instance here, you've launched this EC2 instance here, and you've absolutely validated that they've been set up well. Very cool. It is just wild that all of these learnings are packed in one single project. Great work, and we'll see you in the next one. As we wrap up, a big shout out to Gangada as well for the question. How can I ask doubts if I'm stuck in the middle of doing the projects? Absolutely, all question about the projects can go into the Nextwork community. So the link to that Gangada is community.nextwork.org. So I'll just send that through to you now. So at Gangada, community.nextwork.org is where you gotta be to ask some questions, and as a preview if you like. So this is what the community looks like. Right here is how you will find all of the posts and the questions and documentation shares all in the same place, and we're all doing projects together as Nextwork community members. So absolutely add your questions there, and if you have done this project, add your documentation there too. We'd love to see it. Yeah, a shout out to Julio. Julio, if you're ever watching this, a shout out to you because you're absolutely crushing the documentation game right now. We see you, man. But yeah, this has been so much fun. Thank you so much for doing this project with Nextwork today, because imagine if we haven't been able to do some networking projects together. I feel like we have done so many learnings and there's 2 more projects to go. While everyone's here, might as well shout out everyone in the community leaderboard as well. We've set this up today. Absolutely everyone in the Nextwork community is having huge kudos today, because just this month alone, we've been raking in points. Points and points and points and points. So this is so cool. A shout out to Abhishek for topping the community leaderboard today. We'll see who's going to rise to the top for next week. And in the meantime, a big hug to all of you for being in this community. A big hug to all of you for doing this project with us together today. And we'll see you in the next one. As Joe has mentioned, as Gangada has asked, ask all of your questions in the Nextwork community. We can talk about it there and share your documentation there as well, so we can celebrate together. Alrighty, team. I can't wait to see you in the next project. Joe says, I am not there. You're not on the leaderboard, but you will be in a second. I bet you will be. Once you write your very first comment, you should be in there. Erwin says, cool. Wow, Erwin, good to see you here today. Abhishek says, thank you, Nat. Thank you to you, Abhishek. Thank you for being a top community member with Nextwork. And Ehab says, thanks, Nat, for the great session and love these projects. Was so much fun. Thank you, Ehab. I can't wait for you to try the next one too. That one is advanced, but it is also a lot of fun. Cool. All right. It is the bittersweet moment that Joe was mentioning. It is time for us to say goodbye, but we'll catch up again soon, everyone. See you next time. And yeah, thank you. Thank you so much. Thank you so much for being here. So much love for you. All right. See ya. Bye.